Okay, let's do lecture 7 for phase 2. This is the textbook section 3.2 if you're following the textbook. So we looked at linear functions, linear equations, straight line equations. Those things all mean the same. Now we just want to practice some word problems because this is the skill you want to have, being able to answer more practical, relevant problems. So let's look at example 1. Suppose that a manufacturer uses 100 pounds of material to produce products A and B, which each require 4 pounds and 2 pounds of material respectively per unit. If X and Y denote the number of units produced of A and B, determine an equation describing the relationship between X and Y. So they give me the variable. I'll just write them here to remember what they mean. X represents the number of units for product A. The number of units of product A that I'm making. Y represents the number of units that I'm making of product B. So I just write it down again to remember what X and Y mean. Now, they give me a restriction on the total amount of material. So often, I'm trying to come up with an equation describing the relationship between X and Y. As one change, the other one will change accordingly because I have a limited number or a limited amount of material. So something that might help me to get my equation is to just write an informal relationship in words. So the amount, let's say here, of material for product A plus the amount of material for product B, that has to total the 100 pounds, that's my restriction. If I produce X units of A, how much material did I use? If I use 4 pounds for every one of type A, how much material did I use to make X of them? For X, everyone happy with the 4X? What about the amount of material for B? She says 2Y. So if I add up the material used to make A, add up the material used to make B, that has to equal 100. So let's just put them a little bit closer together. And there's my equation that describes the relationship between the two number of units for each type of product. Now, so as one increases, the other one's going to decrease to give me a total of 100 every time. But this form of the equation isn't as nice for me personally to see how a change in one corresponds to a change in the other one. So I want to write it as y equals mx plus b, because I know how to interpret the slope. This form, for me personally, is a little bit nicer to look at. It's the same equation. All I have to do from this one is solve for y. So I get that 2y is equal to negative 4x plus 100. So y is equal to negative 2x plus 50. That's the same equation. I just like the way this one looks. Because now I can interpret the slope. The slope is negative 2 or negative 2 over 1. How do I interpret the slope? The slope, remember, is the change in y over the change in x. And that is a ratio of -2 to 1. What does that mean? One of the most important things on this topic is to be able to interpret the slope. So what does that mean? So if x increases by 1, that corresponds to a decrease of 2 in y. Now what do x and y mean? I have to go back and remember. X is the number of units of product A that I'm making. So if we make one more unit of product A, then we will make 2 fewer units of product B. I change x by 1, increase by 1, y has to decrease by 2 to stay within the limitation of having only 100 pounds of material. Is everyone happy with how we interpret the slope? It's probably one of the most important things. Interpreting the slope. If one variable changes, how does the other one change with it? Any questions on this? All right. So often for these questions, I type them in a general way. They might not specifically ask me interpret the slope, or if we make one more unit of product A, what happens? But all these questions can easily be asked. So we'll do a little bit more than just what the question is asking. A sporting goods manufacturer allocates 1,000 units of time per day to make skis and ski boots. It takes 8 units of time to make a ski and 14 units of time to make a boot, or a pair of boots. Find the equation to describe the number of units that I make of each and how they are related. So they don't define any variables for me, so I need to go and do that. What do you want for the first variable? X. What does x represent? What does x represent?
8 units of time to make a ski.
Well, not 8. I want to know how many skis am I making. So x, I want x to represent
Units of time to make a ski.
time or number of skis?
Number of skis.
Number of skis. Number of skis. What about y? I guess y could be the other variable. Let that represent the same thing, number of boots. So I'm going to follow a similar strategy to the first example, in that I'm just going to write in words the idea of how I'm going to make the equation. Because now they're talking about the amount of time it takes to make these things. So the time it takes to make the skis plus the time it takes to make the boots has to equal the total time that I have available. How much time does it take to make all the skis? If I make X of them? 8 units of time per ski. So 8 times x. The boots, 14y, and the total amount of time is 1,000. Everyone happy with that equation? Let's put them a little bit closer together. So the same thing as the previous example. This is the answer according to what they're saying here. But the question could very easily ask a question such as, if I make one more ski, how does that change the number of boots I can make? And things like that. It's all interpreting the slope, and for that I need to rewrite this guy a little bit to make it easier for me. So I want to write it as y equals mx plus c, so that I have this slope and I can interpret it. But it's easy once I have this, I'm just solving for y. So I have 14y equals negative 8x plus 100, 1,000. So y is equal to negative 8 over 14x plus 1,000 over 14. Now it's up to you. You can leave it as fractions, or you can calculate it. Doesn't matter.
Can you simplify it?
I can simplify it. What is the slope? I only really care about the slope. Negative 8 over 14. I can write that as negative 4 over 7. Or what is 4 over 7? 0.57 negative. And I can put that over 1 and interpret that. They're all the same. It doesn't matter which one you want to use. So if you want, I think most of you prefer the decimal numbers a little bit. So we can write this as negative 0.57x plus whatever this is. What is it? Anyone have a number here for me?
71.435.
71.43. I'm more interested in this one. How do I interpret the slope? Whichever form you want. Let's use this one first. What is this? How do I interpret this? Well, what's the bottom? This is change in y over change in x. Change in y over change in x. So that means that if I change x by 1, if the number of x is a ski, number of skis increases by 1, then the number of boots, what happens to the number of boots? Decreases by
negative 0.57?
the negative I've captured here in the
Oh,
decrease.
5.57.
0.57. So we have to be careful here. What is 0.57 of a boot? Doesn't quite mean as much. A fraction of a boot. How do you make 0.57 of a boot? So don't be tempted to round this to 1 and then say, oh, for 1 extra ski I make 1 less boot. That's not the case. So because this number isn't very nice and it's hard to imagine a fraction of a boot, there is a benefit to leaving the slope as a simplified fraction, in that each change is a nice whole number now, a nice integer. So there's nothing wrong with that sentence. Or we could say, if the number of skis increases by 7, then the number of boots decreases by 4. So using the fraction form, even if you say an increase of 7 goes with a decrease of 8, doesn't matter. Using this one, the sentences are the same. You can use either one, but this feels a little bit nicer. I'm talking about a change of 7 skis and 4 boots, not a fraction of a boot. Yes?
How do you know if, like, how do you know if you're supposed to use 4 or 3 or
Well, the slope is change in y over change in x. So the bottom guy is the change in x, and x means skis. The top guy is the change in y, and y means number of boots. So I can't swap them. This is skis and this is boots. Because this is x and this is y. Right?
is that like the that's how it's going to be?
This is what the slope is, always. Always. It's change in this guy over change in this guy. And now I just have to remember what they mean and put that into my sentence. And for convenience, I just put the negative with the 4. I could have very easily said, these are all equivalent sentences. They all say the same thing. I can also see the slope as 4 over negative 7. Same slope value. And then I could say, if the number of, what's x? X is skis. If the number of skis decreases by 7, then that is going to give me that the number of boots have to increase by 4. So they're all saying the same thing. There's a 4 to 7 change. Increasing one decreases the other. Increasing that one decreases this one. Doesn't matter how you say it. But it all is in the slope. It's all in the slope. For convenience, I often just put the negative at the top, but it doesn't matter. Doesn't matter. We'll do the slope a few times, every chance we get to practice. One of the most important things is being able to interpret the slope. Yes?
So then what if you had this problem in real life? What would you do to make, if you wanted to make as many skis as boots? Would you be able to use this?
The reason one change affects the other change is because I have a fixed amount of time.
Okay.
So I'm not asking what is the best number of skis. There is just a relationship between the number of skis and the number of boots. If you want to make a certain number of skis, that then affects the number of boots. You could do things like, I want to make the same number, yeah, you could do that.
But you would just have to spend more time making boots. Because they take longer.
It takes longer, yes. So what this on the surface is telling me is just how, if I want to make one more ski, what's going to happen to my boot? And you can determine what is the balance due to some other factors. Yes?
If you said like if the number of skis increased by 2, then how do you know how much is like if you just pick
Okay,
that?
that's a good question. If the number of skis increases by 2, how does the number of boots change? That's your question?
Yeah.
So the reason these questions aren't saying specific things is because there's so many different things that we could ask. We just take the question, set up the equation, and then see what are the different things that we can say. But that's a perfectly valid question, yes. So what do I know Let's call this change, let's call it C. C for change. So C is the change that goes with 2. Okay. Now what does the slope tell me? It doesn't matter, let's stick to my original one, 4 to 7, let's use this one. It's the nicest one, but they all work. So this one says, let's write it like this. If the skis, what do I know first of all? If the skis increases by 7, that goes with a boot decrease of 4. That ratio has to be the same. The slope is always the same. So that has to go with, now my skis increase by 2, and I'm looking for by how much the boots decrease. I'm looking for this C.
Just cross multiply.
Let me just set up my equation to be sure. Increase of 7 goes with a decrease of 4. Maybe this wasn't the best way to do it, but we'll do the other way in a second. It doesn't matter how you set this up, as long as they have the same on the same side. An increase of 2 in skis goes with a change of C. So I cross multiply. 7C is equal to -8. C is equal to -8 over 7. So it decreases by just over a boot. You could have also said, to make it more consistent with the slope, I suppose, skis increase, no, not skis, boots. Let's stick to this. That's the boots, that's the skis. So boots decreasing by 4 goes with skis increasing by 7. I have to have the boot to ski ratio the same. So now the boots change by my unknown C that I'm trying to find. And that goes with the skis increasing by 2. So I have a decrease of 4, increase of 7, a change C going with an increase of 2. But the result's the same. Cross multiply, C is the same. So it doesn't matter which one you have at the top and which one you have at the bottom. As long as it's the ratio, skis to boots change. So we're spending time on this one, which is good while the questions come up. And they all have the same issues. We do the same thing for all of these questions. Whether it talks about boots and skis or type A and B products, it's all the same. Any questions on this? So maybe this one is a little better because it looks exactly like the slope. The slope is the same, regardless of what exactly my change is. There's a corresponding change in the other one. Okay, let's look at number 3, but before we do that, I just briefly want to talk about supply and demand. If you're not in the business program, if you are in the business program, then you've seen supply and demand curves probably a lot. If you're not, it's worth just mentioning how these things behave. So I have some product and we'll represent the price P per unit of the product, and we'll represent the quantity Q as the number of units of the product in a certain time period. Let's say like a week. Depending on the price, the number of units that people want to buy might change. So there's a relationship between the price and the number of units in demand. So there's a price-demand relationship. If my price increases, what does that do in terms of the demand? The number of units that people want to buy. If it's if the product becomes more expensive, what happens to your willingness to buy it? It's going to decrease. I'm not willing to buy it if it gets more expensive. And on the other hand, if the price decreases, that's odd, that goes with an increase in demand because the product gets cheaper, I want to buy it, or I'm more willing to buy it. So if I make a sketch, Q on my horizontal axis, price P on my vertical axis, if the price goes up, the demand decreases. So I have a lower demand with a higher price. And if the price decreases, the demand increases. So I have something that goes from the top left to the bottom right in some way. I don't know exactly how, it depends on the actual problem, the actual product, but something that goes down to the bottom right. Similarly, there's a relationship between the price of my product and the number of units the supplier wants to give me. If I'm selling this product and I can get a high price for it, maybe the supplier is more willing to give me the product. If the price increases, what happens to the supply? If I somehow manage, it's Halloween, if I somehow manage to sell pumpkins at a high price, the farms are going to want to give me their pumpkins. So my supply is going to go up. On the other hand, if I'm not very good at selling pumpkins, I have a low price that I'm selling them at, the farmers wouldn't want to give me their pumpkins. So I again have, if I see this graphically, if the price goes up, the supply is high as well. And I have something that changes somehow from the top right to the bottom left. Does that make sense? Familiar? I don't want to do too much on this. It seems intuitive. The price affects the supply as well as the demand. So question 3, and there's a homework question as well, is based on supply and one of the two, supply or demand. So I have my demand curve and my supply curve.